So let's get started on today's MacBook. Today's MacBook is a 15-inch touch bar machine, and it doesn't work. The problem with today's touch bar is that when you plug in the charger on this machine that has been messed with before, you can tell it's been messed with before for several reasons. It's missing little rubber pieces on your plug. You always want to make sure you have a rubber piece over your plug. You know, you can get in trouble if you don't. So there's supposed to be little rubber pieces around the plug over here for protection. It is missing the jumper on the lifeboat connector, so it's never going to see the internal SSD because it's not plugged in, and it's missing a shield. There's all signs of messery with this. Anyway, the issue that we're having with this is that it is not giving ourselves a charging voltage. And I want to really keep hammering home the standard issues with this new MacBook, with the new charging circuit, and again, with the older MacBooks that had an orange or a green light in the charger, the first rail you needed was PP3V42. PP3V42 is what allowed your charger to communicate with the system management controller chip. Now, there's a different power rail that's your primary rail that you need, and that is PP3V3 underscore G3 hot. That is the rail that you need in order for the charger communication to work properly. And I really want to hammer this home so that people get used to it. So why is it that you need that rail? Well, that's a great question. So you have these chips that communicate with the charger. So we have the CD3215 charging IC, and what this does, this is going to allow the volt power from the charger through to the computer by allowing this transistor Q3100 to open, and B, it's going to negotiate charging voltage. Remember, with USB-C, we don't just have one voltage. MagSafe chargers put out one voltage, 18.5 volts. USB-C chargers can put out 5 volts, they can put out 20 volts. There are different voltages they can put out based on whether you're powering a USB flash drive, a cell phone, or a laptop. And they need to negotiate with the charger what voltage it's going to put out. That communication is going to occur via the CD3215 chip over here. And this chip, the CD3215, needs PP3V3 underscore G3 hot to go into it in order for that to work. So, as can be seen, via the USB-C amp meter, which is imperative if you're going to be working on these machines. I say imperative, as imperative as a bench power supply. As you can see here, we are getting a reading of only 5.21 volts. So the charger is not able to communicate with the rest of the system, and that means that the CD3215s are not doing their job. Now, are they not doing their job because one of them is bad? Or is it not doing its job because it's not getting power? That's the first question you should ask before mindlessly replacing a chip.
Have a good weekend.
Good night, Paul. And now, the way this works, for each USB-C port on this MacBook, you have a CD3215. This port, CD3215. This port, CD3215. And the two ports on this side each have a CD3215. Now, what's tricky about these machines is if even one of those chips is not communicating or not working properly, or if even one of those chips is missing from the board, any one of them, none of the ports will work. I repeat, if any one of those chips that communicates with the charging port is not functioning or missing, none of the ports will work. So even if I'm trying to only use this port on this side of the board, and this CD3215 that corresponds to that port is good, if this chip is missing, that port will not work. Great design, Apple. Great fucking design, as always. Now, let's get into troubleshooting this board. So the first thing that we're going to do is take a look over the board in those areas and see if there's anything that's obviously wrong around our CD3215 chipsets. Do keep in mind that some boards underfill them and some boards don't. So if you see corrosion, do not go to blindly reflow things without checking to see if yours is a board that has underfill. Because if your board has underfill and you go to reflow the chip, very bad things will happen. All right, so these CD3215s so far look pretty clean. Ass is just $2 Australian. Oh, I was reading it as ass. Maybe I'm just being dumb. So these CD3215s look pretty well to me. Again, I can't really see under the chip from this angle, but they look fine. So what I'm going to do is see if they're getting the power rail that they need in order to turn on. And as I've said, that is PP3V3 underscore G3 hot. So we're going to check for that rail right by the chip. We're going to check on this capacitor over here. We're going to check Paul Daniels' amazing software and pray to God that it actually works and see if a multimeter shows up on the screen. And wow, Paul Daniels' software actually worked and the multimeter showed up on the screen. Imagine that. And we're getting 1.6 volts. 1.6 is not 3.3. That's not going to give us a working board. So I'm not going to blame any one of these chips, and I'm not going to blame the charging port. So what we're going to do over here is we're going to check out where PP3v3_G3 hot is created from. Where do we find that on this motherboard? Great question. Now, something that seems to confuse a lot of my students, and I mean ex-students because I don't teach anymore, if you're interested in taking a course on how to do component-level rework on MacBooks and iPhones, check out MendonIPadRehab.com. That's MendonIPadRehab.com or iPadRehab.com, where you can find Jessa Jones's course, Practical Board Repair School, that I taught at for 6 months before I almost choked Jessa out of our standard back and forth, constant bickering and arguing. But no, just kidding. Jessa is amazing, and Mark Schaefer is amazing, and they will teach you board repair very well. And if I sign up 3 people for their course, Jessa will come down and help me fix boards so that I can actually take a day off and go see the neurologist like I was supposed to do 2.5 months ago. So, don't delay. Check out Jessa Jones's Practical Board Repair School course today. If I get 3 signups to her course, that's 3 signups, she will come down and replace me for a day so that I can take a day off and go to the doctor, which I would very much like to do. Now, going back to this board, PP3v3_G3 hot. How is it that we find PP3v3_G3 hot? Well, what we need to do here is find out where it's being created. And a problem I noticed a lot of the time when I was teaching is that people seem to be very confused in how to find where a power rail is being created from. So they can find out where that power rail is, they can find out where it is that the power rail is going to, but not where it's being created. So let's see if we can find that by using Paul Daniels' software. So here, PP3v3_G3 hot is going into a resistor. That's not it. We're looking to see where it's being created. This is PP3v3G3 hot powering something, not it. So we double click again, and as you'll see here, it's going into something again. That's not where it's being created. We're going to double click, and nope, PP3v3G3 hot going into something, not coming out of something, so that's not it. I double clicked and it didn't work. Thank you, Paul Daniels, for the... We're going to double click again and see if it works. And PP3v3G3 hot is going into a chip. So that can't be it. All right, we're going to keep going. Because this is a very common question that a lot of the students will have is, how do I find out when it's coming out of something? So double click again. That's PP3v3G3 hot going into a keyboard connector. Not it. PP3v3G3 hot going into a U5000 to power it, to turn on. PP3v3S5 SMC VDDA. Not it. All right, let's keep going. We're going to keep clicking. Is this it? No. This is PP3v3G3 hot being used to pull up 3 signals. It's going to pull up these signals of SMC PMIC int L, SMC on-off L. This head tick is driving me nuts. And SMC TMS. Not it. SMC, okay, this is obvious because it literally says over here in. So that's not it coming out of something, that's it going into something. Next. That's it powering a logic gate. Next. You get the idea. So that's not it. That's it going to a Hall effect sensor. That's a sensor that's going to detect when it is your computer closes, which is what was keeping that kid's MacBook from working the other day. You know, the kid that Apple told his MacBook Air needs a new GPU. Gotta love the Genius Bar, man. All right, so we continue clicking, and I think you get the idea at this point. So here we go. This is the screen that I'm looking for. Any tips on how a broke female dog like myself can learn or get experience doing board repairs so they can try and get a job working for a handsome, generous... you can watch these videos for free. 110% free. Watch these videos and you will learn. Paul learned how to do 90% of this from watching my videos. I really didn't train him, seriously. Like, he asked occasional questions, but for the most part, he would just figured it out from watching the videos. This is what we're looking for. This is where PP3v3_G3 hot is coming out of something. So what does this chip do? This looks a lot like the PP3V42 power supply of olden days. We have from USB-C source. It's going to take this voltage in, the 18 volts in. It says 8.6 volts because Apple is terrible at writing a schematic. Great job, jackass. Really, you're telling us that the battery voltage is 5 volts above the charger voltage. You stupid. Anyway, that's for another day. So the 18.6 volts that's coming in from the charger is going to go to this chip. This chip is going to reduce that voltage to 3.3 volts. This is 3.3 volts coming out of something. So this is the area that we want to look at. This is where PP3V3_G3hot is being created. This is where what we're interested in is. So let's take a look at that section on the board. So I'm just going to click, and it's the magic of Paul Daniels' software. When you right-click on U6903 using Flex Board View, it brings you right to that chip on the board view. Paul Daniels, engineering software of tomorrow. Now, we're going to take a look at that section of the board over here, and let's see if we can find it and see what it looks like. And oh my God, what did you do? All right, so let's try and figure out what they fucked up. So I'm going to plug in the charger, get the volts reading on the screen. So let's go over a couple of things in the schematic now, shall we? The first thing I want to go over is the voltage that's coming into the chip to turn it on. And that's going to be voltage that's present on pin 2. First thing we're looking for, pin 2. Pin 2 is going of U6903, is where the power is going to be going into U6903. So let's check that out and make sure we're getting a proper voltage there. Are we getting the input from the charger? We're getting 3.89. Well, that's no good, because we're supposed to be getting 5 volts from the charger. So let's check at D6902. Let's take it back a second. Let's check at pin 1, where the charging voltage is supposed to be coming in, which is supposed to be 18.5 volts, but is going to be 5 volts here because the USB-C charger is not communicating with the system because PP3V3_G3hot is not present yet. So we have 5 volts there. We have 3 volts on the other side of the diode. All right, now that's interesting. So either our diode is bad, not likely, or there's a short after the diode, very likely. Let's see which one it is. So we have 7 million ohms after the diode. 7 million ohms. So there's no short after the diode. Now there could just be a 1 volt drop after the diode, which, a little bit, that's understandable. Let's see if that's what's going on here. The line. My multimeter probes are kind of nasty. So we have open line. And we also have open line. So, and we're in diode mode. So my diode does not appear to be properly passing current. Pole voltage. Electrons is whatever the hell you want to call it. My head is fried, man. I need a day off. So, oh, I got a message. I missed it. Uh-oh. Oh, it disappeared. No! There's got to be it. I never have the window open to read the messages. With brain damage and constant work, you should be nicknamed Candy. You know what? I'm not going to Google that, because if I Google it, it's probably going to depress me. All right, so let's see if our issue is the diode. We're going to remove this diode and replace it with a better one. A fitter, happier diode, with less brain damage. Bye-bye, diode. Fitter, happier, more productive, not thinking too much, more exercise at the gym, still kisses with saliva. I'm going to listen to Radiohead today when I get home. So many mouse pointers. Oh, so you see it too. Thank God. I thought it was just me. Yeah, that would have been awkward if it was just me. It's really nice when you think you're seeing things and then somebody else sees it as well. It's nice to know that you're not completely crazy. Partially crazy is fine. Completely crazy, no. Alright, so replace that diode with a better one. A superior, fitter, happier, more mother effing productive. diode. Now, might as well put that cap there that the dumbass knocked off. And 2.2 microfarad on input. After diode. Alright. Let's put that capacitor there. Capacitor. Oh, this is going to be great. This is going to be great, man. It's going to be a beautiful working little board. I like to think every time one of these boards work again, there's some... I like to imagine Angela Renditz crying just a little bit more when somebody's not going to her store to give her more money because something is working again. So every time I attach one of these little components, I just imagine that. And it makes me a little happy. Maybe I'm crazy. Maybe I'm sick in the head. Maybe I probably was. That's probably what suits me so well for this job. But I like it. I am me. Alright. That's in there. That looks beautiful, beautiful. We're just going to cool that circuit off a little bit. We're going to plug this thing in. And I'm 110% confident that it's going to give me 20 volts on startup. I'm not even going to measure anything here. Not even going to check. I just know this shit's going to work. I have confidence that that after 12 hours of working, that this board I fixed is going to just work on the first try. It's confidence right there, man. It's confidence. Watch this. Check this out. Confidence is what makes boards turn on. Look at this. 1, 2, ready? 3. 20 volts, baby. Oh, yeah. Look at that. Look at that. Check that out. Check that out. 20 volts. Charging voltage. Haha. Don't forget to remove the J tag. Oh, gonna murder that J tag, bro, but we're gonna do that off stream. Gonna wait for this to be done. Look at that. Look at that. Look at that. That's booting voltage. All right. Let's check out and see if we got an image next. See if we got an image. You good folks think I got an image? I hope I got an image. And let's see if we got an image. You think I have an image? You think I have an image? All right. Let's see if I got an image. Let's hope. Because if I have an image, that's another board that's been fixed. Okay, we're just going to do that. Gonna plug this thing in. And we're going to get a question mark folder. Because there's no lifeboat jumper, but that's fine. Can you find me a lifeboat jumper? Beautiful. After you find my replacement. How's it going finding my replacement, by the way? A few runner-ups? Mm-hmm. Where'd you find them? I'm so excited. Oh, God! No! That's where all the terrible things have been coming from to begin with. Okay, let's see what we get. Show me a picture. Even if you're a question mark. Don't make me hold this like this. Oh, this is so sad. I have to hold it like this until I get a question mark. All right, as you can see, I have a question mark folder. That question mark folder means that I fixed my board, which means I can go home. Because that's the last one, right?
No.
No?
No.
No?
Not at all.
What do you mean it's not the...
That's not the last board.
That there's more?
There's way more boards.
How many more?
Like, too many to count. But you can still go home now if you want.
But I'm tired. I want to do. I'm tired of fixing MacBooks. I want a day off.
Take off tomorrow.
It's impossible.
Take off the next day.
They'll just call and bitch. Why isn't my Mac done? Why isn't my MacBook done? You said it would take 5 days, and it's 4 days and 20 hours. Why isn't my Mercury Facebook machine ready? Well, fuck you. Ugh. Time to continue work. I'm gonna go and find yet another MacBook. But this one right here, it's one less MacBook to do. It's been fixed. It's been a MacBook that has been fixed. See you in the next one, if I still have my marbles, which I probably don't. That's it for today, and as always, I hope you learned something.